So vectors, just put a heading now, vectors. So in a vector, sir, whenever I ask you vectors, na, one thing I want to be very clear, because this chapter will help us the utilization of vectors, because without the vectors, sir, we cannot imagine this chapter. Okay, are you getting my point here? Without the vector, you cannot imagine this chapter, because the chapter name is, what is it I told you? Motion in a plane, yes or no? Which is I can say this is fourth chapter according to us. Sorry, third chapter, right? So motion in a plane. Now tell me, what is the motion in a plane according to you? Plane. Motion in a plane. Plane is a should have a two axis. Welcome. Plane should have a two axis system. Two axis system. One second. So plane should have a how many axis system? Two axis system. Yes, I know plane should have a at least how many axis, buddy? Two axis should be there. So this plane here itself a two axis system means you can have a xy plane, you can have a yz plane, you can have a zx plane. Am I correct? Means if I take the this is a reference frame for us, which is x axis, y axis and z axis. Am I correct? This is one plane which is a xy plane. What about this one here? YZ plane. What about this one here? ZX plane. Plane. Yes or no? So plane in the sense the particle can cover both the distances. Means along the x-axis and y-axis. Yes or no? If I consider one of the plane like this. Okay. This is a plane. So in this plane, this is the x-axis. This is y-axis. So something you thrown upside. Like for example, obliquely one object is thrown. Like this you thrown. Yes or no? What it does? So it will go like this and it will fall like this or not. Yes or no? Means each position, if I try to see this position, it would have actually covered a distance of x distance from here. Yes or no? And it also covered a y distance from the vertical. Means it is covering horizontal and vertical at a time. Yes or no? So this motion, what we call it here? Motion in a plane. So to deal certain questions now, we will take the help of what is that here? Vectors. Okay, so vectors are perfect to define the position vector. Yes, it is like if I wanted to show that the value of it, so I can show the value also. If I want to show the direction along x, y, z, I want to just multiply with the unit vector. It will automatically give you what is it? It will give a vector along the x direction. Now, for example, so vectors you know already. It will definitely consist of what is it here? Magnitude as well as what is it here? Plus a direction. Obviously this one should have what is it here? Magnitude and direction. Okay, so we'll start with that only. So obviously this chapter without vectors we cannot imagine this chapter, as I told you, right? So put a heading now, vectors. Okay, so vectors are, this vector concept will help us to write the magnitude plus and the direction of the parameters. Yes or no? Motional parameters. What is motional parameters? So you know already initial velocity, final velocity, acceleration, displacement, yes or no, etc. These are all four basic parameters in this chapter also, and this will give you what is it? The direction of the this parameters as well as magnitude and direction of the parameters can be seen with help of what is it here? Vectors. Yes or no? Yes, no doubt. So we'll because you study more about it in a math, yes or no? But we need only some part of the math that we want to show the position of the particle, position and the position vector. Position and position vector. So no, what is this one here? Position and position vector. Means you see position means I'll take the axis system here, three-dimensional axis system. X-axis, Y-axis, and then we have it as a Z-axis also. X-axis, Y-axis, and we have a Z-axis also. Along the X-axis we have a I cap. Along the Y-axis we have a J cap. Along the Z-axis what we can write is K cap. Right? What are these things? We know that already. I already taught you. I cap, comma, J cap, comma, K cap are, what are these? Unit vectors. What are these here? Unit vectors. Okay, unit vectors. Means they show the direction. I, if I mention, it is the showing the direction towards X direction. J showing direction towards Y direction. K showing the direction towards Z direction. Am I correct? These are positive. If I wanted to show negative, negative also. Negative x-axis will be negative I cap. Negative y-axis will be negative y-axis, negative j cap, negative k cap, like that we can write, okay, for the respective axis. And their magnitude also, what is that? You know magnitude, how to write mod function. Magnitude of these functions, these vectors are, what is it? Right? It will be equal to 1. That's why they are named after unit vector. What do we call them? Unit vector. Right? Simple. Very simple. Then what about this pointer? This point we call it as a reference point, or else we call it, what we call here, observing point. Okay. So this reference point has a, what is the reference point? 0, 0, 0. Means we will always think from the observing point only. Where are we right now? According to where are you? You are actually at a reference point. Yes or no? Now you want to observe certain things. Like for example, you know we are living in a three-dimensional world. Yes or no? Three-dimensional or four-dimensional? Three-dimensional or four-dimensional? Three-dimensional. Yes or no? We are living in which world here? Three-dimensional world. Yes or no? So obviously, for example, there is one of the flight like this. Okay, like this there is a flight, and you are working in a airport. Yes or no? So you are a ground staff. You are working. You are signaling them. So where is it located? This aeroplane is located. Tell me. Where is it located? So some position, okay, some random position like it is located. So position of this one is, what is it here? X1, Y1, Z1. Can I write like that? Where are you located? You are located at this position, means at a reference frame you are there. So you are actually working here and you are actually guiding this plane, right? So this is a position from the reference or not? Why? Because from the origin this aircraft is located at X distance, Y distance, Z distance. Can I say like that? Yes or no? So, okay. Now this is a position. I wanted to show position vector. This is a vector or not? Position vector R bar. What is this? I told you this is just a point, right? Or we can call it as, what is it here? This is simply a position. Then what about a position vector? R bar is a position vector. What is this? I told you, position vector. Yes or no? Position vector can be written as x into x1 into I cap plus a y1 into j cap plus a z1 into k cap. You have already studied a coordinate geometry, right? Yes or no? So you studied coordinate geometry only as a magnitude, only as a point. But now we include some direction to it. Are you getting my point here? We are simply adding some direction to it. It becomes, what is it? Vector. So no? Are you going to study as a direction cosines in math also? Got it, right? So in 10th standard you studied as a pointer, but here you are adding some direction also. Yes or no? So we know that if why do direction is important, maybe this flight is going, coming, landing, whatever, some activity it might be doing. So you are observing it like this. Can I say like this? Now for example, there is one more helicopter. Can I draw like that? Okay, something sort of. Okay, someone is driving a helicopter also here. Where is it located? So it is located from here to here, somewhere like this, right? The position of this one is different or not as compared to this one? Where is it located? So it may be x2, y2, and then this will be z2. Can I write it like that? So can I connect with the which vector? Let's suppose I wanted to show the direction of it now. R2 vector. R2 will be what is it here? Position vector. Q is the position for us. Yes or no in this situation? Q is the position. Am I correct? Then what about R2 here? R2 bar is a position vector. How do you write it? So x2 comma I cap plus y2 j cap plus z2 k cap. Am I correct? The position you have converted into what is it here? Position vector. Yes or no? So that we can show the direction of this helicopter also. Can I say like this? So this is your position vector. Am I correct? Draw this one. Note. Fast. Write down. Is it done? Okay. Shall I move on? Okay. Next, now a few things we want to study about this vector. How to find the magnitude of vector? Yes or no? Shall I do that? So one after the other we'll learn it. So first one what I am going to do is find the magnitude of the vector. Magnitude of the position vector. Magnitude of the position vector. Can I? We have a position vector r1 bar is equal to what can I write? X1 I cap plus y1 j cap SNO plus z1 k cap. Can I write like that? Magnitude means just take a magnitude here. Magnitude of this one mod function under root of what is it here? This coefficient should be squared. Yes or no? So we can write x1 square plus y1 square plus z1 square. What is this one here? This is the magnitude of the vector. Yes or no? Now, for example, I can also create certain thing now. One example I will try to take it here. For example, now if for example 2I cap, so one A bar is equal to some position, random position vector, 2I cap minus j cap plus k cap. Okay, then find the magnitude of this one. Now, how do you find it? Same way. Find out. Do it. So under root of what is it here? 2 square plus minus 1 square plus 1 square. So total answer will be how much here? 2 plus 1 plus 1. So your answer will be root 6. Son, root 6 some units. Maybe this position vector they will write a units also. So we'll write it as a units. Can I write like that? Son or some units. If I mention meter, it will also meter. If it is centimeter, centimeter. Mm. Okay. Oh, sorry. 2 plus 2, 1 plus, how much right it will be? 2 square no. 2 square no. Is it done? Any difficulty? No. Shall I? Arey, you both stop your romance for a while. Okay. During physics class only all these things are. Hmm? Shall we move on? Next, if I ask you something else here, for example, logic you should understand. There is a find the find the unit vector for the position for a bar is equals to x1 I cap plus y1 j cap plus z1 k cap. Okay, unit vector you need to find x1 I cap plus y1 j cap plus z1 k cap, which is equal to what is it here? Let's say 2 I cap plus j cap plus 3 k cap. Okay, what did I ask you? Unit vector I asked you. Means there will be formula for it. You know, in a math we learn that formula. Here also we learn that formula. Unit vector for r bar, or if I say a bar is equal to xi cap plus y1 j cap plus z1 k cap is, what is that now? Unit vector is written as a cap. What is that we are going to keep? A cap. Yes or no? It's a unit vector. So a cap is equal to what is it? I'll write a bar dot mod of a bar. So at last means unit vector in the sense you have this position vector. At last, which direction it is moving? Yes or no? At last it should move, right? Like for example, there is, I mentioned some bird is actually like this. There is one bird is there. Okay, so this bird is actually flying here. Which direction with what value it will move? Yes or no? Then you need to always have a unit vector of anywhere, any position vector. So now for example, now position vector, what is this one here? This is a position vector. What is this one here? Position vector. So how do you find a unit vector for this one? This manner. Okay, so what is that I can write? A bar to we already have. A bar value is how much you have? 2 I cap plus j cap plus 3 k cap you already have. Magnitude of a bar is how much you tell me? Root of 2 square plus 1 square plus 3 square. Total answer will be how much here? Root 14. Can I write like that? Root 14. Now a cap will be, what is that answer? So unit vector formula here I am writing. So a cap is nothing but what is it here? A bar dot magnitude of a bar. That's it. So what is the answer I can write? A bar total value you need to write, which is a 2i cap plus j cap plus 3k cap. Yes or no? Divided by, what is it here? Magnitude is how much you got it here? Root 14. Yes or no? Shall we move on? Next, relativity between a vectors. What is that here? Relativity between a vectors. Which vectors here? Basically, position vectors. Yes or no? I wanted to create what is that here? Relativity. So same diagram I am going to take it now. For example, like this. This is a x-axis for us. This is a y-axis for us. This is z-axis. Reference position. Am I correct? Now there is a, for example, I wanted to say there is a two things are there. Okay, one aircraft is here, another aircraft is here. Okay, or else we can say, what can I say? Sorry, one balloon. Okay, balloon going upside. So this is located at a, from here to here it is a R1 position. It is located. It is located at a R2 bar. Yes or no? R1 bar and R2 bar. Now what is it R1 bar? R1 bar we know that it may be the position vector is x1 I cap plus y1 j cap plus z1 k cap. Yes or no? Next R2 bar is equal to what I'll take here? What can I take it? X2 I cap plus y2 j cap plus z2 k cap. Can I take it like that? Relativity. Relativity is nothing but I will compare. Now what would I compare? For example, imagine ourselves. Let's take it as some airplane only. Let me take it. Okay. Okay, two airways basically, two airplanes are there. This is at R1, this is at R2. Some position, random position. Now basically, you understood this one, right? So I wanted to create a relativity. Relativity, na? For example, you see R1 cap means definitely we should show vector na the this arrow mark should be there. Yes or no? This also what is arrow mark should be there. Now I want to compare from like this. I want to compare. What is this one here? R12 bar. What is it? R12 meaning you know already. R12 bar means what is that here? Position of what is this? Relative position of R1 bar with respect to whom, right? R2 bar. Can I write like that? We have studied a relativity, right? In one dimension, same thing here. So what is it? I can write it here simply R1 bar minus R2 bar. Okay, R1 bar minus R2 bar. So in a space, we don't know where to take the sign, positive, negative, we don't know. But here I can simply write R1 bar minus R2 bar. Clear? So what is it now? Tell me how? Because this both are in a, it's a clockwise direction. This is anti-clockwise, opposite. Clear? So what is it here? R12 bar is equal to what is it? R1 bar minus R2 bar. Clear? So what is it? I'll get it here. Now R12 bar na. So you write the formula here. We have it as a x1 I cap plus a y1 j cap plus a z1 k cap. Yes or no? Minus x2 I cap plus y2 j cap plus z2 k cap. So what is a R12 bar? I'll get it here. So I'll get it as, so only x coordinate X only we can add or remove. Yes or no? So what I'll do it here, x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. Can I write like that? Can I write or not? So mod of magnitude, I want to find this one. Magnitude will be, what is it? Can you tell me just formula? What is it become? So the coefficient of this I will be, what is it here? X1 x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. This formula somewhere you would have seen, right? When distance between the 2 points. You have studied it or not? But what are we doing here? We are actually using the vector. Means direction you are showing. Yes or no? So the coordinate geometry, means the magnitude, if you add the direction, then automatically it becomes a vector. Clear? That's why vector has a magnitude as well as a direction. Yes or no? Is it done, buddy? Any difficulty? So if I wanted to write a relative position of R2 with respect to R1, what happens here? Here x2 I cap, x2 minus x1, y2 minus y1, z2 minus z1. Yes or no? So you are comparing the from where to where here. Let's suppose this is at a P position, this is at a Q position. You are comparing from the second to first. Then also distance magnitude will be same or not? Same magnitude will get it, but the direction will be different. Clear? So what I'll write here? So note, you write down one note. What is the note now? Direction wise, if I check it, R12 bar should be equal to minus R21 bar. Direction wise, what is it? They are opposite. Magnitude wise, they are equal. Is it done? Now, next put a heading, parallelogram of vector addition. What is that? That's it. Parallelogram of vector addition. Vector addition. So you cannot add the vectors normally, but we will use the vector parallelogram law. Vector addition will use it. Yes or no? You know that how parallelograms are there? Tell me. So before that, let me just remind you. So parallel side of the quadrilateral should be equal. Yes or no? They are in the same direction. Let's see. So parallel side na, this is one vector. Okay. This is another vector. Two vectors. Am I correct? Two vectors. Just name this one is a P bar. This name is a Q bar. So both are in a different direction. Are you getting my point here? This is P bar and this is a Q bar. Right, right. अरे वो ग्रीन टी शर्ट का बाजू वाले क्या कर रहे थे? What's his name? that fellow. Come here. Yes or no? Now what happens here? P bar and Q bar, okay, both are actually practically two vectors are acting in this manner. The resultant would be plan to kidnap any kid here. Yes or no? You're gazing them, literally. They'll scare with you, idiot. Uh, P bar and a Q bar, yes or no, both are acting in this manner. Let's imagine vector example I told you. What is it? Velocity is a vector, acceleration is vector, force is a vector. But you are more affection will be there for a what is it? Force or not? For example, two people are there. Okay, this P bar and Q bar, they are pulling one of the block here. Which direction this will move? This is one block is there. Which direction this block will move? This P bar is pulling this direction, Q bar is pulling this direction. Which direction it will move? In between like this it will move Will you agree or not? Yes or no, re? You didn't pull anything at home. Pulling, pushing, force. See your now two people are there, buddy. Simple here. P bar is one person, Q bar is one person. Which direction this will move? In between away from it. It will move in between. Am I correct? Like this? Stop watching some stupid cartoons, idiots. It will move like this. Practically, it will move like this. Yes or no? Okay, I'll connect it very nicely. Now, for example, P bar is a Nainatara. Okay, we like Nainatara, right? Most of 99% movies are Nainatara only here. Yes or no? Whenever I keep her channel, obviously it is Nainatara, right? What about a Q? It will be definitely Vijay. 100% it will be Vijay. Okay, there is no doubt. Okay, being a Vijay fan, you should accept it. Yes or no? Now Q bar is pulling in this direction, P bar is pulling in this direction. Which direction this ball will move? So obviously not towards P bar, not towards the Q bar. In between it will move. Yes or no? That will be your resultant effort. Am I correct? So I am saying that two vectors, if they act like this, now the resultant will be like this. So this looks like, for example, if I show you, so if I try to just connect it, Q bar, can I connect the Q bar like this? Parallel only, no? If I connect it like this, it is what is that P bar? Parallel vector. Parallel vector. So it looks like what? Parallelogram or not? Yes or no? Initially, angle between the P and Q is how much here? Theta or not? Initially they are theta. Now this is the resultant I told you R bar. This R bar is coming because of what is it here? It's coming because of the P bar plus Q bar. Am I correct? P bar plus Q bar. Now this makes an angle with any of the vector. So basically I am taking here because this is exactly horizontal, so I am taking with this one alpha. Can I take it like that alpha? Yes or no, right? So alpha is an angle made by whom here? A resultant vector. Am I correct now? Any difficulty? No. Now come to the scene here. So you see this is a P bar. This is similar. This vector is similar or not? Yes or no? Now means if I just extend this line like this, again this line is Q bar only, no? Yes or no? What is the angle between them here? Theta, right? What is the angle between them here? Theta. If I drop down one of the line like that, so what is this one here? It is a vertical line. Now you see this is O, this is a, this is a B, this is a C. Can I write it as a D? Yes or no? Now you see this is a parallelogram, but you see O, B, C, D is a perfect triangle or not? Perfect triangle? Yes or no? This P bar, now I will divide. How would I divide? Basically, if I say any vector, if it is working, I already taught you in the bridge course also. If any vector is like this, P bar is like this, now I will make the angle theta. Yes or no? I will resolve. This is called vector resolution. Yes or no? So intensity of P bar will be resolved along x axis and y axis. Along the x axis, what it will become here? P bar cos theta. This is what is this here? P bar cos theta. Vertically, what is this one here? Vertically, this is a P bar sin theta. Yes or no, right? Triangle, you know, right? Trigonometry you would have studied. Studied or not? What is this if I say it is a x? If it is theta? Yes or no? Cos theta is equal to what is that here? For example, you know that is, for example, I am taking this as a r. Some random, anything you can consider. Like for example, trigonometry also I should teach. This is a x, this is a y, this is z. Can I take it like that? Cos theta is equal to what did you study? Horizontal means adjacent side by hypotenuse. Adjacent side is what is that here? X. Am I correct? Ayo, all local brand effect. No. This will be what is that? Z by x. Very good. So it will be z by x. So z is equal to what it will become now? Tell me. X cos theta or not? Yes or no? Similarly, y is equal to what can I write here? X sin theta, can I write it like that? Yes or no? So this will be horizontal direction will be what is it here? P cos theta. Vertically this is a P bar sin theta only, no? Yes or no? So instead of showing here, I am showing on the axis itself. Can I show like that? Yes, of course you can show. So along the x-axis here, P cos theta. Along the y-axis it is a P sin theta. Can I say like that? Now here you come to this point. P is divided or not? Yes or no? So here what it will become here? This will be P bar cos theta. Today something is happened to this. P bar cos theta. What about this one here? P bar sin theta. Can I take it like that? Means the vector is divided, its intensity is divided along a vertical as well as horizontal. Now you see from the triangle, which triangle now I am taking? OBC, big triangle. Yes or no? From there can I write it as OB square is equal to what can I write here? OC square plus can I write it as a OC square plus a BC square. Can I write like that? Yes or no? Next step is what is it here? OB square is equal to OC square is nothing but what? OD plus DC, can I write it? Whole square, can I write it? Then what is it here? BC square. Can I use it like that? Then apply the value. OD means what is that? Right? P. You take only the magnitude, right? What is it here? Magnitude. So magnitude means P bar magnitude OD. I'm sorry. This is Q bar, right? This is Q bar. I'm sorry. Then what about DC, buddy? DC will be P bar cos theta. So take the magnitude only. Okay, P bar cos theta whole square, and BC will be what is it here? BC square. Okay, P bar magnitude, what is it here? Sin theta. Can I take it like that? So I am just taking the few points here. P bar magnitude I am taking it as a P. Is it okay? Q bar magnitude I am taking it as what is it here? Q. R bar magnitude I am taking it as what is it here? Is it okay? Now O to C, O to B, what is it here? R bar only, no? It will be R bar magnitude only, no? R bar magnitude whole square, can I write it or not? So total answer will be what is it here? R square is equals to, it will be written as what is it? Can I open it? So it will be Q square plus P. So can I write 2 PQ cos theta? Can I write it like that? Yes or no? Next step is what is it here? P square cos square theta, can I write? And here also there is a square, right? We missed it. So it will be P square sin square theta. Can I write it or not? Yes or no? Now write down. Note down. These arrow marks are important. Please draw like that as it is. But you open those windows. Shall I move forward? Is time over? So at last what I'll write is the equation you can note down. Magnitude we can write, then the direction tomorrow I'll write about it. So what is that? I'll get simple logic here. Simple logic here. So what I'll get it here, magnitude of r bar is equal to under root of. So if I just rearrange it, p if I take it common, what happens here? Cos square theta plus sin square theta. It will be what is that here? 1. So your entire answer will be p square q square and then 2pq cos theta will be the magnitude of the resultant. This is the magnitude of the resultant. Okay? So for now you write this much only. Tomorrow I'll discuss the direction and related. Okay? You can move now. Thank you. Start.